And then you have Pi is equal to Ti omega I. Again, this omega is not been given, for example, you can also look for gear ratio relationship. Look at this one. They provide you this one, right? So you need to know what the omega is. So this done. Okay, the overall efficiency power transmission of the system. The overall power transmission is basically coming from the equation one. Coming from this one, the overall is equal to PO by PI. If you have only one input and one output. But this one you have two inputs, so you have two outputs. So this one PO for the grinder plus PO for the drum divided by PI. This one all calculated. And calculated this one, just put in number. If you don't want to use this, if you don't want to use this one, you can also use in other form of equation, which is you expand the equation becoming this one plus TD omega D divided by DI omega I. And you can expand the equation becoming TD, this one is TI, this one becoming one N, isn't it? N for G and I. Plus this one is TD divided by Ti, and this one also becoming your N, D, and I. Okay, so you can choose one, but I might advise you to use this one because you already calculated the PO and also PO for grinder and drum respectively, and even the PI also be calculated. So this one is better still, yeah. Number 5, suggest one method to significantly increase the overall efficiency of the pump transmission system. Explain why. One methods. How are you going to increase the power transmission? How? Explain. Then you explain. How is it? Okay, no one does know the question, the answer, so you have to look at on your own one, yeah, or find out on your own. Yeah? Number 5, increase the torque, yes, correct, and also you can check also the gear ratio, the gear ratio and also torque, yes. Without calculation, if gear 7 is disengaged, this one is suddenly now this one is now been snapped. Sorry, it's highlight. You cut that one. Okay, so what does the question say? So calculate the input torque of the engine in steady condition. What does it mean? In steady condition, what does it mean? This one is the A equal to 0 or perhaps alpha equal to 0. Doesn't matter which A and doesn't matter which alpha. If you concern about AI, for example, so this could become A alpha I. Isn't it? So when this one is not connected to gear 1, so you have only a single branch. So which connected 2, 3, 4, 5, and 6. This one all already calculated. You just use the equation, or perhaps you use the numbers or value, and you get it together as you understand how to go about it. For example, look at here. You have the equation Ti plus To equal to I. Now only for grinder. You don't concern about this one anymore because you now cut into 2 pieces, or perhaps it is not connected. Then you have this one, FB refer to I, plus this one becomes 0. The reason is why, because you have I, correct, I equivalent refer to I, but the alpha is itself 0. So this one then depend only here, and this one. Very fast, Yeah, you this one, 2-3 minutes, inshallah. Okay. Any other question? The last one. So that's about it for the first part. So if you practice, that's why I give you more works. Even though you know that I know that most of you grumble behind that. It might cost so many work. This is the reason I give you work, because at the end of the day, at this time, for example, you don't have to do anything, because your tutorial be all are being compiled and you know all this solution. Then you just get together and just flashback whatever you learned or perhaps whatever you done earlier. For those problem that you are not attempt, you can look your friend's solution, isn't it? Okay, so we move to the next one. This one in Bahasa. The other one, so remember this. If you keen to look for the Bahasa Bahasa text, this is a Bahasa text, Bahasa Melayu text. If you found that any numbers or any data which is contradict with English, English with the prime. Okay, use English or your prime. I'm not saying that Bahasa is not prime, yeah, in this matter, because we basically design the equation in English, then we translate in Bahasa. Okay, so English will be the prime data. Do not just ask around or ask friend or ask lecturer. No, just go to English and take the English data. This is the other question for gear system. So if you choose this one, so you don't have to choose this one. You don't have to do this one. But if you keen to do this one, it's not very difficult anyway. So look at the part A. What is the epicyclic gear? What is the epicyclic gear? Everyone knows it's comprising of what? Sun, isn't it? Annulus. What else? What else? Planet, isn't it? Four main components. Yeah. Describe briefly two distinct advantages using the epicyclic train as compared to parallel train. What is the parallel train? The parallel train is hoist. So what is the distinct advantage? The parallel train, you hold one, the whole gear will not move. But the epicyclic, you hold your log, any part of the gear, the other gear is still operating. So that is the most distinct advantage. Yeah. Okay, this one for number 2 is also not very difficult. So you have a couple of gear here. When this is a simple gear train. Isn't it? Connected. One gear carry one. One shaft carry one gear. And they provide you all numbers here. So you need to know. You will need to find what. Well, with this arrangement, find the speed and direction for gear number 7 here. This is the input, gear number 1, gear number 7. This one you can do on your own. It's not very difficult, isn't it? It's very, very simple. You start by saying, remember, we learned N17, for example, is equal to, or this is omega O by omega I, then all the gear. 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 4, 5. 5 is not connected to 7, but 6, 7. Okay, this one is not very difficult. Find also the gear ratio of the gear. The gear ratio is omega O by omega I. It's not very difficult yet. They provide you the speed. So what will be the speed for the last gear for the output? Number 2. The epicyclic gear. So shows the top half of the compound epicyclic gear. This one with input shaft I. This one is input. Rotating constant speed 500 RPM clockwise and providing 500 watt input power, and the transmission efficiency is 90%. If the speed of annulus A2, this one is A2, is rotating with 150. This one is rotating with 500. Ignore. I'm not putting the units here because it's a small space here. Just put it 150. But this one is speed. Yeah. Find the velocity of annulus A1. Find what is A1. The O here and the Z here. Okay. So that is not very difficult. You have 2 train, you must have 2 tables. So now, could anyone tell me you have 2 tables? Absolutely, you have 2 tables, correct? So the first table, which will be the first table? Train number 1 or train number 2, and why? If you understand that one, you can proceed with the solution. Train number 1, correct? Why train number 1? Actual one. Look at it. Train number 1 don't have any actual arm, isn't it? Train number 1 don't have any actual arm, Correct or not? Common arm. Virtual arm. Correct. Yes. So in my class, in our class, where is the what they call it there? Good idea to start with the simplest one, either train one or train number two, and then reasoning. Which one? Train one and train two? Train number one. Not train number one, yeah? Not train number one. It's train number? Train number? It's train number two, isn't it? Train number two. I'm not saying when you use train number one, it's not correct, yeah? I'm saying that if you start with train number two, it's much easier rather than start with train number one. That is the idea. I'm not saying that when you start with train number one, it's not correct. It is correct. But it is more simpler if you start with train number two. The reason is why? Why? This one? Anyone remember what we studied in class? So why train number two considered as train table number one? Why? Why? No? Okay, this one you find out. Why? It's not because virtual arm.
This is because it's at
Yes, correct. Because the external gear acting as an arm. Look at it. Because of this. Because the external gear acting as an arm for the next train. Okay? Because this A2 acting as an arm. Because why arm? Because holding P1. So that is the reason why. Because it's connected to the next train. This one you can do on your own, yeah? Okay? So you can do on your own. It's not very difficult. So if A2 is locked, then you lock A2. If A2 is locked, find the gear ratio, correct? And the episarchy gear, the output torque, and the torque required to hold analyze A2. Okay, it's also not very difficult. So you can check this one on your notes. And you also, this one, sorry, you also, done this on so many times in your problems. Huh? Yes, thank you. Yeah, those who respond, thank you. Yeah. So now we move to this one. Question number 3. This one, look at the answer all question. Just now one, choose jawab satu soalan saja. This one, or perhaps answer one question only. Okay, answer all 4 questions. So number 1, look at here. Show the disturbing mass MA lying on plane A. MA, where are you, MA? MA here lying on plane A, correct? Which to be balanced by 2 mass. This one must be balanced by this one and this one. It is correct. Lying in 2 different planes, plane B and plane C. The 2 planes are parallel. 2 planes, this one are parallel. 2 plane A are all parallel plane. Then this one, when you look at one point, you're becoming as such. This one, your eyes is at one end. Then you look at this one. This one front view. Look at it. This one side view. This one is front view. Front view. This one is side view. So by considering the centrifugal force in static, look at it in static. Prove that this one equal to this one and this one given as this one. And it's not very difficult. This one is very direct. It's very direct. It is very direct. Okay. Static condition. When static condition, you know what is static condition, isn't it? Okay, and you know that this RB, look at the RB and RC, this one also triple time. This one, that's why you have triple time here. So this one RB, this one is RC. This one you can do this one on your own class. It's only carry 2 marks anyway. This is the other possibility which is more challenging. Figure show 20 kg shaft. The whole thing is 20 kg. Support by bearing P and Q. This one is P and Q. Is this one P and also Q. The shaft is initially totally balanced. What does it mean? So it means that, initially there is no radius of eccentricity, meaning that your R radial density is equal to 0. Or the center of the radius of eccentricity of fall at center of rotation. The two bolt, this one, bolt B and bolt C, two bolt, 0.2 kg mass are fastened at plane B and C, and C. Angle given 90 and 0 respectively. 90 for B, 0 for C. Determine the following: the dynamic force in terms of omega acting on the bearing. This one, what you have? You have B, C, P, and Q. That's about it, isn't it? Because the rest is balance. You know MB. MB they provided 0.2. You know the direction, 90 and also 0 degrees. The required mass to be added. This one, the required mass to be added, and their angular position if the correction mass to be applied on the circumference of A. This one. Then you have to put something at A. Then you also need to put something at D. This one is the balance mass. And we need to know what be the MD, and also we need to know what the M and A. To add is become positive. This one, yeah, to add is become positive. So you will have M, A, M, D. So this time around, your plane will be A, B, C, and D. So there is no P and Q, because PQ doesn't concern, because PQ is only concerned when you're talking about force. Okay. So you must have two. You must have what? You must have two one. You must have two. You must have two one class. Two tables. Yes, you must have two tables. One table when you are dealing with forces. So, for example, this one. This one, question number one. Question number one. Put it here, force. So your concern will be is a plane PQ, BC. So PQ, BC, PQ, BC. So P, put it there, P, then you meet C, B, then you meet C, then you meet Q. This one plane, isn't it? P, B, C, Q. Then you have mass, as usual, mass. This is not our concern. You have M up, P. This is our concern, B. Provide here. What does B give you? 0.2. Added. This one added because you fasten this one extra mass, added mass. So you have 0.2. Both are 0.2, right? Yes, two bolts, 0.2. So this one is 0.2. The other one is also 0.2. This one is, sorry, this one is not correct. This one is not correct. It's supposed to be no mass concern. This one, no mass concern, no mass concern. Then you have arm. This one, no radius. This one, what will be the radius? Pick up the radius. Radius is 200 becomes 0.1. This one also same thing. So 200, 0.1. This one is 0.1. Don't have concern. And the units. The next one be, this is your concern, M arm. So this one become M arm for P. This one has 0.02. 0.02. This one is M arm Q. Isn't it? Then look at the D. As what we do, as what we did in class, and with all the example you already done. D. So D pick up 1. CP will be your reference plane, becomes 0. Then look at what B. B respect to B. You will have this one reference plane. You have B is here is 150 by 50 become 200, 0.2. Put it here, 0.2. Then C, go back here. What C is? C will be here. C here, isn't it? So you add up another 150. So 150 and 150 you becoming 300. So this one 0.3. This one you have the MRQ. The next one will be sorry. Astaghfirullah. That one also D. This one will be D. Here add up another 100. Isn't it? So you become 0.3, 0. What just now? Q is this one is 0.P, 200, 300, Q this one 400. So you have 400. Am I correct? 200, 200, this one 250, 350, 450. So 450. So you have 0.45. This only MRD 0. This one you have the number, this one becomes 0.004. This one you have 0.006. This one you have 0.45 MRQ. Then the position, they provide the position. Look at here, P. You do not know what P is, but they provide you 90 and 0 degrees. So this one is 90. This one is 0. This one is theta Q. Theta P. This one is theta Q. Then you need to follow. You need to follow the what? This one given clockwise. Look at the reference viewed from left. Left is here. Your eyes here. Right? So clockwise, horizontal. This one clockwise, horizontal. 180 to 70. Then you construct. You can construct. You can use the what do you call it? This analytical. Okay, I'm not going to do this one. Yeah. So first construct this one, isn't it? Construct this one. Then you get MRQ. F equal to MRQ. This one FQ multiplied by omega square. Omega square is not concerned because in terms of omega. Okay. Then do another time. This one known. You have this one P. Exactly as what you learn in class and also your exercise or problem. Yeah? So for table number 2, I'm not going to construct table number 2. Yeah. For table number 2, this one will not be compliant anymore. Because table number 2 is talking about what? It's talking about adjustment. Adjust. Hello class. Everybody is still still with me or this one is no more your concern. This one also no more your concern. Isn't it? So all the numbers now, this one is not correct. 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 This one is correct. But you have another parameter, which is the question asks you to pick up a plane of what just now? A and D. So put it here, A and D. Put it have A and D. So what will be the A and D? We do not know. Okay, put it here. This is I am A. This one is MD. You add up positive, positive. Radius, they provide you the radius. The radius of A is 100. AD is 160. So it becoming 0.5 and 0.8. This one is 0.5 and 0.8. You have this number 0.5 MA. You have this number 0.8 MA. Then you pick up one to become your reference, isn't it? So let's say you pick up A as a reference. So as A as a reference, this one becoming 0. So to D, A to D, A to D, A to D will be the whole range, isn't it? Become 200, 250, 350, 450, 450, 500, 600, so 0.6. So you will have 0.6 here. Along the line, this one is 0.6. And this one will be a new numbers here. Then you construct another, you construct or you draw another polygons. Okay? I'm going to share with you this one, then you do, next step, yeah? Okay? Any question? So what else? What does the question need now? Okay, that's about it for question number B. So we move to question number 4. Number 4, yeah? Number 4. Question 4. So now, what is question number 4? Explain briefly with sketches the term logarithmic decrements as applied to damped vibration system and 3 different conditions of damping coefficient. damping condition, remember this one. Remember about equal to 1. Remember equal to, sorry, greater than 1 and also less than 1. Greater than 1 and remember this one is less than 1. 3 different conditions of damping coefficient. Explain the term of logarithmic decrement. How is it? It's not very difficult, isn't it? So the logarithmic decrement, this one is also known as x1 by x and is equal to 2 pi and zeta is, this one is small n, yeah, it's not big n, small n. And this one is 1 minus zeta. Okay. So this one is what? Is the ratio. What does it mean? It simply means that if you have a graph, the graph, let's say the graph is starting at here, for example. So this is the exponential. This is what? The exponential graph, isn't it? Exponential graph. So that is why you have ln. Remember this one? X equal to exponential st. This n is what? Is the number of cycle. N is number of cycle. How many cycle? 1 cycle. The zeta will be, you have the oscillatory. This xn will be this one, this x1, and perhaps this one will be xn. So if n equal to 1, so x1 and x2, for example. Okay, it's not very difficult then. And the other equation here to share with you is the, remember the thing that we learned in class. You have ZAM, isn't it? You have very short, and you have okay. Can check this one. Critical mean this one is zeta equal to 1, zeta greater than 1, zeta less than 1. This one a periodics. This one also a periodics. This one is periodics. I don't explain too much because it's only carry you to 2 marks. You have to just your own time. Yeah, manage your own time. Don't spend so much time on explaining things. Just put it here now. Predict no motion, oscillatory. Get full mark, inshallah. Huh? Okay, the vibrating system here, this one provided here, consists of what? OAB, correct, and a send cut. This one is a send cut. This one, yeah, a send cut here. This is the send cut. Okay. What does it say that send cut D of unloaded mass of 2 kg, unload of 2 kg, so empty meaning empty, and a lump mass of 2 kg. This one is lump mass. This is a lump mass. What else? Fixed at point E. This is fixed at point E. Fixed at point E. This one, yeah. It means that it will not move. It cannot be slide, just fixed, fasten, whatever it is, as long as it's fixed, it's not move. The mass of the rod is 3 kg. This one, the rod, this one is 3 kg. What else? In elastic, of course, and the radius of gyration is 0.5. This one is 0.5. So the radius of the rod provided. So you don't have to use the equation that coming from the TPS, or what is TPS? Is the theorem of parallel axis, isn't it? What else? Look at it. The cut D is connected to rod by an elastic cable through a pulley of mass 0.5. This one, yeah. This one mass. Jot down in your notes, because you can easily understand what happened to the system now. is then loaded with sand. Then you fill up this one with 8 kg. Initially, it's only 2 kg. Now you fill up with another 10 kg. 8 kg become 10 kg, the whole mass now. So the 2 kg is basically because the empty container. Then you add up at 8, it become 10 kg now. So the motion system is regulated by 2 spring damper. This one, yeah, 2 spring damper. Look at them. By 2 set of spring damper system as shown. 2 set. 1 set, another 1 set. Then what else? The system is disturbed by giving the cut. This one, you move the system by x dot, x double dot. You disturb the system. Initially, it's in the equilibrium condition. As you disturb the cut, it will be oscillating, isn't it? It will move back through and back, isn't it? So the system is disturbed by giving the an initial displacement of 5 cm. This one, you push this one, x equal to 5 cm. Then you let it go. Then you release. It will be vibrating. Okay. Then find what will be the omega and the damping ratio zeta and the displacement of d after one complete oscillation. This one initially was 5 kg as 5 kg. It's not. Initially was 5 cm. Then when you let it go, the amplitude becomes shorter and shorter. It will not become 5 cm but some other form of value. So the next one will be the minimum mass of the sand. What will be the minimum mass of the sand to be removed or to be added from the cut for the system to reach critical damping? Simply mean that zeta equal to 1. Explain your finding. The friction between cut and surface pebble pulley are negligible. So there is no friction for every parameter here. Okay, so that is how you want to understand the system. So initially you have the choices to solve this one by using Newton's law, or by using by using equivalent system. So suit yourself. If you want to use for Newton's law, it's not very difficult anyway, because you just want the whole thing you put at A, then you'll be rotating about D. Okay, but when you want to look for equivalent method, you also need to use SA as point of reference, because A will be the connection between the rod and also the pulley. Okay, so suit yourself. How are you going to solve this one? So if I owe you, for example, I love to solve this one by using analytical Newtons, but yet I know that most of you love to solve this one by using Newton, not Newton law, energy method. So let's start by using energy method. So how is it? I'm going to clean up this one a bit because I need to draw this one next to next, because it's easy, but then I flip over here and there. So let me push this one. Okay. So now this one, D is here. So just put it here. Or perhaps better still, if I put it here, this one. Do you have another space? I don't have any space. Never mind, put it there. Never mind, I put it there. This one is D, isn't it? D. Then we have this one is A. This one is your A. This one is A will be 0.4, 0.4. Correct? Then you have how many mass? Remember, 1 mass, 2 masses, 3 masses, isn't it? So you have put it there all in block. This one is ME. Put it there, ME. It is no longer ME, become ME prime. What else? We have another one. This one is the MD. Put it MD. Also prime. You have another one. This one is the what do you call this? Pulley. M pulley. It's also not M pulley, become M pulley prime. And this M pulley is not rotating about D, isn't it? It's rotating about its own fixed point. So put it here. So, with the radius of 0.1. And you have another one, the rod itself. The rod itself. So put it at the rod itself, put another mass. M, put in the M rod, easy. M rod prime. Can you read, class? Hello, can you read this one? Yes or no? because it is superimposed to the next the equation. Okay, thank you. Yeah. So then the whole thing, this one, will be attached to or controlled by this one, spring, zap, zap, zap. This one, another one. This one is KT. KT total, yeah, is equal to, you have this K2 prime, bring the K2 close to the A. This one, you don't have to do anything because as you go along and you follow the chord, it will be fall and A. So plus K1. Same thing for city. Same thing for city. Equal to, this one is C2. You move C2 from the B to A. And this one, you don't have to do anything. Just plus C1. Okay. If you can also put this one, you can also put this one here, downward, doesn't matter. Because again, I remind you, this is not the free body diagram. Okay, this is not the free body diagram. You put this one is correct, you also put this one is correct. As long as you understand what are you attempt to, yeah? Okay, so you're going to look for omega n, for example. So the omega n is simply given by the equation of what? K by m, remember? But now you are doing the, equivalent. So it simply means the omega n is equal to KT by m, t, all prime, prime, prime. This one representing by this one, all mt prime. This one is your KT prime, KT prime. You add up to get this one, you have the omega. It's not very difficult, isn't it? It's not very difficult. Eh? You can do this one on your own. Eh? Okay, what else? To determine the zeta. Remember zeta? Zeta can only define by two ways. Isn't it? One will be C equal to 2m omega n zeta. The other one is, remember, the logarithmic decrement by using or applying ln x1 by xn equal to 2 pi n here zeta. This one is 1 minus zeta. But very unfortunate, this one will not provide you any of the parameters. So you cannot use this one as part to calculate zeta. It's not zero, yeah? Cannot be applied. It's not zero. It cannot be applied. Cannot be applied. So you use this one. But remember, this is not C, but C, T, prime, the total one. Remember, this one is not M, it's M, T prime. The omega n calculated earlier, then you know what zeta. And obviously, zeta must lie between this one. Can you understand that? Hello? Okay, yeah. Do this one, yeah. This one become your one. This one become your one. This one become your individual assignment. I already mentioned about that one just now, isn't it? Don't worry. The date time will be 1 day before the exam date. This one become your individual assignment. When will be the due date? The due date will be 1 day before your exam. Your exam is 11, if I'm not mistaken. So it's the 10th of February. 11, as usual, 11 p.m. I'll be remind you later on, yeah. Okay, but don't worry, if you don't want to do this one, you don't want to submit, doesn't matter, but you get 0 for that. That's the one. Yeah? I'm applying the Newton's law. Action equal to reaction. You react, I give you action, you react, I give you mark. If you don't react, I give you 0 for that. Yeah? It's very simple in life. Yeah, life is full of choices. Okay, next. The displacement of cut D after one cycle operation. The displacement of cut D. So how is it? How are you going to do this one to check what with the displacement? How is it? Use this equation. Ln x1 by xn is equal to 2 pi n zeta pi. 1 minus zeta square. Zeta calculated, isn't it? Zeta calculated. Zeta calculated. N is given. How many cycles just now? N is 1 cycle. N is 1. N is 1. What else? Zeta calculated and one, okay. Then what else? What is your, you will be getting from this one, yeah, you'll be getting the result, you'll be getting x1 by x, isn't it? You'll be getting such, and is equal to exponent, the whole thing. Astaghfirullahaladzim. Exponent of the whole thing, which is 2 pi and zeta divided by 1 minus zeta squared. You'll be getting this one, numbers. Let's say you get this one 2, for example, yeah, for example, let's say you get 2. Okay, as x1 is equal to 5 cm, isn't it? Because they provide just now x1 equal to 5 cm. So the x2 will become what? The x2 will become? The x will become, no, 5.3. Correct, it's 5 by 2. You'll be getting 2.5 centimeter. For example, yeah, this is not this. This is not the sorry. This is not the answer. Yeah, this one. Let's say equal to 2, for example. Okay. Any question? It's not very difficult, isn't it? Okay. Now next, the minimum mass of the sand required to be removed or added for the card for the system to reach critical. So what do you understand by critical? At critical condition, what do you understand by critical condition, class? What do you understand by critical condition? Anyone? Correct, zeta equal to 1. So remember, C is equal to 2m omega n zeta, isn't it? Can also be in the form of what? It can also be in the form 2m. Omega n is k by m, correct? This one is zeta. Isn't it? It's equal to, this one will be, you know, what are you k by m zeta. So what you have is you will have 2m power of 2, this one k by m, this one zeta. Cancel, isn't it? Zeta square, sorry, zeta square, this one c square. So finally, it can also be in the form of c is equal to, this one be what? This one 2 square become 2. This one k is square root km. If the critical condition occurs, so the zeta now equal to 1, correct? So your C now is equal to 2 km. Am I correct or not? Yes or no? Yes or no?
Doctor.
Yes or no? So, but remember, yeah, our concern is not C here, because you're talking or you're dealing with what? Equivalent. So this one is CT. This one also MT. This one also KT. All are already calculated earlier. So if you can expand a bit, for example, yeah, CT will remain as CT, of course, equal to 2. But this time around, KT is also remain as KT. But this MT, remember just now MT, what do you have for MT? Well, you have the MT as, remember, M rod, MP, MD, and E. You cannot choose, you cannot, what do you call it? You cannot change MD, cannot change ME, you cannot change M rod. So put it here. So this one MD cannot be changed, plus ME cannot be changed, plus M, what else just now? Rod also cannot be changed. The only thing you can change is the M cut, isn't it? M cut yet. So this is a new one. So you have to ensure that when we're getting here MT, you equate this one. For example, yeah, for example, look at here. For example, after calculating this one, you get the MT is equal to 100 kg, for example, say. Okay, so then you put it there. Okay, MT, now MT new is equal to, put it there. MP, you calculated as, let's say, 20 just now. ME, you calculated by 10 just now. The M rod, you calculated by 50 just now. And plus, this one is M cut. This one now is 100. Is equal to, this one what? Cannot change, cannot change, cannot change. This one is 3080 plus M cut. But remember the old one has what? 8 plus 2 equal to 10. Correct, no? Yes or no? Yes or no?
Yes, doctor.
So how many mass you want to add now? So you have equal to 80 plus this one be 10 plus M new equal to 100. Am I correct or not? Yes or no?
Yes, doctor.
So how many how much sand you want to add to the system now? So your sand is equal to 10 kg. Become equilibrium, isn't it? So that is the calculation. But if for example this one only 50, let's say 50. Let's see, 50. So you have 50, but yet this one also big. This one you cannot do anything about it. So what be your reason? Because the equation say that explain your findings. So let's say now it is 50. So your finding is 50. So if 100, okay, correct, because you have to add this one, add, correct, yes. But if 50, if your MT prime is 50 kg, so what be your reason now? So if you don't want to respond this one, I also don't want to answer this one. What is your finding now? Nope. Okay, no one want to answer. So no one to. Yes.
By adding mass, I think.
No, you cannot, because you the MT 50, but you have this one 80 plus something. So what is your finding now? What is
Reduce
your finding
mass.
now? Sorry?
Reduce the mass, I think.
So critical, look at here, condition. What does I put that one? Critical condition not possible to occur, isn't it? So there is no way critical condition will be occurring because this one is so small, so you cannot do anything about it. Okay, so this is your finding now. Critical condition is not possible to occur. Okay, I'm going to move to the next one. I have another couple of minutes. This one, here, the force derivation. Force derivation. So for the force derivation, explain briefly the term of transmissibility. I think everyone know what is transmissibility. You can check on your notes. What is the maximum factor? But if you have this one, for example, if the question provide you this one, for example, I'm not promising you anything at the moment now. Let's say they provide you this one. So the transmissibility is what? This is the definition. Right. For the harmonic form, the transmissibility is defined by the force transmitted divided by applied force. Okay, pick up only one. Don't pick out so many. For example, okay, this one. What else? What if you found that it is not critical? Sorry, it is not. Where are you just now? This one, you have magnification factor. You go back to the figure. You go back to the what's that? The metric equation. The magnification factor. So the magnification is basically this one divided by this one. You hold on, I got a call from one of my colleagues here. Okay, sorry guys. Got call from friends. Huh? Okay, now go back to this one. You still with me, class?
Yes, doctor.
I seldom not pick up call, but this is call from one of my colleagues. Yeah? So I'm sorry, keep you waiting just now. So anyway, the magnitude factor here, this one. Okay, the magnitude function is defined by the amplitude of this state divided by static. This one is static deflection. That one. So this is not very difficult. Only carry couple of marks here. And we move on to look at what the amplitude state, for example. So this amplitude state and natural frequency force in force then vibration. So you can do this one on your own. Yeah. So the most important thing I think will be the second part of part B equation. Look at here. A mechanical shaker with mass 150 kg, illustrated figure 5, contain two shafts. Look at here. You have two here. M here, another M. Look at it, you have two mass. This is the unbalanced mass. Two unbalanced mass. Yeah? So if this one will be rotating and this also rotating, so it will be creating this one. It will be creating this one, remember? And this one will give you M E omega square. Same thing here. M E omega omega. Omega is obviously omega F, yeah? It's omega square. Omega square, yeah. Okay, so if you go back to the equation saying that, okay, the out of balance each match is equivalent to here, ME, to provide you ME is equal to 1.15 kg meter, isn't it? Sorry, the out of balance mass, it's not meter. At radius 50, to provide you 50, the shaker is attached to the rigid plane and supported by two vibration isolator, each of which has a combined characteristics of a linear spring with constant spring of 400 kilonewton per meter, and also the spot will give you C, for example. So the system can be assumed to have 1 degree freedom. So this one is the assumption to have the 1 degree freedom, and it's in a vertical plane only. As I put it here in vertical plane, even though you know that this one be have a horizontal and inclined force. But we are assuming that only vertical plane. Okay, number one. When the shaker running with a constant speed of 2000 RPM, for example, it's observed that the amplitude state force is given by this one. So the amplitude state is given by 0.8 millimeter. So now construct free body diagram of figure 5 and derive equation of motion. It is not very difficult. It is not very difficult. The construction of a free body diagram will be how? This one will be, you can put this one upward, downward, doesn't matter. And this one will be your ME omega square. But not to forget, you have 2 here. Put it here 2. Correct? What you have L? You have this one is, remember you have 2 here, 2K. You have another one, 2C. Isn't it? Then we have equal to, it's supposed to be the other side there, but there is no space, so I put it here. So this one now, tell me whether it is pointing downward or pointing upward. My MX double dots. Pointing upward or pointing downward? Upward, yes. So how do you know? Because follow this one. So this one pointing upward. MX double dots. And this M is belong to this, the whole M. The big M. This one, the small M is belong to the small M here. Then your equation becoming summation of F equal to MX double dot. So saying that pointing upward as positive, you are saying that you have 2 small m E omega square. We do not know whether sine or cos, doesn't matter, isn't it? Is equal to, this one you have 2K plus 2K plus, sorry, this one is KX. This one is CX dot. I'm sorry, I missed one point. This one is KX. This one is 2CX dot. Then you arrange the equation becoming the equation. Correct or not? It is correct or not? Correct or not? It's not correct. You have another one, this one. It's not correct. You have this one. Okay. This one plus what? MX double dot. Plus MX double dot plus MX double dot. So M, this one is a big M. Okay, so this is your equation. Also not very difficult. Huh? Then the value of decimal C for each member, and then when you have to find C. So how do you have to find C now? How are you going to find C now? How are you going to define C now? So then you need to put all the numbers here. Just remember that this M is a big M. Big M, yeah? How are you going to put, how to get to C now? Use the amplitude of steady state. From the amplitude of steady state. How do you know? From the amplitude of steady state, this one, amplitude of steady state is equal to, how? Is equal to F naught by K, isn't it? Divided by this one. This one is 1 minus R square plus 2 zeta R square. The F naught itself, don't worry, if you forget this one, you go back to the equation because you know that you've been provided the equation, so you go back to the equation here. Look at here, you pick up one of the equation given, you find out the equation is this one, use this one. Okay, so the amplitude state, if I can simplify this one, it become the ME, become ME big M R square here. This one is 1 minus R square plus 2 zeta square, and yet equal to 10 times 10 to the power of negative 3. Look at what is the omega F by omega N. Can we calculate the omega F? Yes. Can we calculate the omega N? Yes. How do you know, how are you going to get the omega N? The omega N is calculated because the equation doesn't give you what K is, isn't it? It doesn't give you what K is. Do the equation give you K? They do not. Yes, K. Yes, sorry, K. They provide you K. They also provide you M. So that one is very easy for you to define. Yeah. Just remember that you know this what do you call it? This 400. This one is not the 400 because you have 2K here. You have 2K here. Look at here, 2K. So you have omega N is equal to 2K by the big M, by the big M. This one is capital M, and the big M is the capital N. Okay, you have the omega N. What is the omega F? What is the omega F? How do you find omega F? How do you find the omega F plus? How? How? Anyone? Anyone? How do you find omega F? Come on. Look at the equation. How do you find omega F? Yes, omega F. I think one of your friend already, answered the omega. How to find the omega F. So you can calculate the omega F on your own. The next thing is to define omega F is basically the speed is given here by 2000. So omega F will be divided by 60. Yes, correct. So you have the R, correct? You have the zeta calculated earlier. Then you know what will be the MEM. Then you have the, you have the M, so you have the zeta. Please be ensured that zeta must lie between this one. This is the range of the zeta. Okay, I think that is not very difficult for you to look at. As you get the zeta, then you put it back. C is equal to 2M omega N zeta. Put it here, then you have the. But remember this one, yeah, it's not small m. This one is the big M, capital M. Okay, the big M. The small m only used for the unbalanced parameter. So what is the next one? A couple of minutes. The value, correct, the force transmitted. Force transmitted is not very difficult. You go back to the equation here. Force transmitted is this one. Isn't it? You have omega F, you have E, so on, so you have the Ft. It's not very difficult. The next one, after force transmitted, I suppose it will be transferability. The transmissibility also not very difficult. So look at here, the transmissibility at steady state and during resonance, and comment your answer. What does this mean? So you have to look at two. So you have to look at two. Yeah, one will be when your transmissibility, go back to the equation, this one. This one is the transmissibility. The transmissibility here. This one, yeah, the transmissibility when what? When resonant are equal to 1. The other one, transmissibility when steady state. Steady state mean what? You have all numbers. It's not equal to 1. So then you compare. Which one will give you worse? Whether resonant or a steady state. Then you comment on your own. And of course, you understand that when you come to resonant, you're becoming what? You're becoming so severe to the system. That one is so natural, so logics. Finally, you have a last one. This one, what is the last one? Explain what happened to the force at the horizontal component of this body. So now, I'm going to clear this one so that we can, we can explain what happened to the horizontal force. I'm going to use another color so that it can easily to differentiate. So you know well that if supposing this one you have at this end, yeah, at this point you have this one. This one is ME omega square. This one so ME omega square, isn't it? This one you have ME, same thing, omega square, right? So same thing here, you have ME omega square. You have also here ME omega square. So now tell me, what happened to the horizontal force? What happened to the horizontal force now? This one also we have ME omega square. So could anyone tell me what happened to the horizontal force now? Yes, you cancelling each other and it will be automatically balanced on the horizontal plane. Thank you, yeah, for your response. Okay, now, last but not least, we have a couple of 14 more minutes. I think I did mention this one in last meeting, yeah, about the, the 2 degree of freedom. Concerning about this one, one will be you have to, simplify this one from the very, from the very complex, if I may say this one, to become more simpler form, which will be in the form of this one. This one be the simplest one. And this one be your K equivalent. This one your M, and you have this one will be X. So this is the simplest one. So first is look at this one, these two. Correct. This one become 2K. You have one spring, this one 2K. 2K and K, isn't it? In series, this one in parallel, this one in series. So you start doing another one. So this one, you add up together. It's not add up together as the normal additional, yeah? Use series, which is 1 by K, 2K plus 1 by K. You have this one. This one is not very difficult. You have K, this one 2K, 3K by 2. Okay, 2K, 3K by 2. Yes, correct. Yeah? 3K by 2. Yes, no? Sorry, 3 by 2K. Oh, I'm sorry. Sometimes my mathematics is so. 3 by 2K. 3. This one 3K, this one square, 3 by K. Okay, 3 by 2K. Then this one you have 3 by 2K. This one become parallel. You add up together. So you can do this one on your own. Then you add up together. This one becomes series and series another time. Then only you have the the actual system. This one. So this one only carry at least 2-3 minutes. It's not very difficult. And this one is more challenging. This one, they provide you as such. Show bodies M1 and M2, springs 1, 0.5, 0.5, all 0.5, except this one you have K. Parallel arrangement for the given system, derive expression of equation motion, frequency equation, mode shape. This one is very typical. So this one you add up together, become K. This one you add up together become 3K. This one you add up together become 2K. So your system will becoming, you know, this one spring, mass, spring, mass, spring. It's not mass. This one, if you have another mass, become 3 degree of freedom. Spring. This one will be K. This one M1. This one become 3K. This one be 2K. So your M. Of course, there's no friction. Okay? So how is it? It's not very difficult. So you pick up one of the example. As I suppose that if I manage to put here x1 and the other one be x2, so you have choices to say that whether x1 is greater than x2 or otherwise x2 is greater than x1. So if you start thinking about x1 is greater than x2, so your solution become as this one, yeah? This one, okay, let's start with spring, mass, another spring, another mass, another spring. This one, you end up with a fixed point. This one K, 3K, this one is 2K, isn't it? This one is M1, this one is M2. Then this one is X1, this one is X2. Okay, so say X1 is greater than X2. So start construct the free body diagram. So your for the free body diagram will be start with M1, correct? Start with M1. Put it here. Okay, M1 is here. This one is X1, correct? This is fixed. Yeah, fixed. So as you move this one to X1, so this K will not allow you to move. So you have the K here is a storing energy to bring back the M1 to the origin position, becoming KX1. And this guy, this 3K, also the same thing. Also, you know, again, the motion you have 3K, but this one is X1 minus by X. Okay, if you already practiced on so many times, you can also construct another free body diagram, which tell you that M2, this one is X2, isn't it? Same thing, correct? So this one, what you have? This one will be your 2K. 2K X, X1 X, X2. Yes or no? This one becoming M1, M1 X1 double dot. This one becoming M2, M2 X2 double dot. Yes or no? Agree or not? Agree or not, class? Anyone? Isn't it? It's better
Yes.
still if you can do both, yeah? Yes?
Can do like this, put two get together.
Yes. As long as it's correct. Then you start thinking, okay, I'm going to start with this one, for example. But this one, do not do this one, yeah? Do not do this. This line, yeah? This just one, just to separate this one, yeah? Okay, do not do this one. This is just to show that first I'm focusing to this one, then I'm focusing to this one. Don't do this one, this, or the jagged line here, okay? So, okay, summation of F equal to Mx. This one 1 double dot, 1 also, saying that move that one positive. So I'm collecting this one becoming negative Kx1, negative 3Kx1 minus X2 equal to M1 X1 double dot, isn't it? Then you solve it, M1 X1. If there is no force, if there is force, we have another force, yeah? Double dot, bring it the other side, so become K1 X1 plus this one is K2, this one be X1 minus by X2 equal to 0. One equation. Then you start thinking, okay, I'm doing the other one. So now, still focusing on this one, but looking this one. Again, do not do this, the green line, do not do in your test, yeah, exam, yeah. Summation of M M2 X2 double dot. This one is 2, this one is 1 just now. So saying that it's removed this one as positive. So we are collecting all the parameter which is given here. So you have the 3k, this one, yeah, x1 by x2. This one minus by 2k x2. This one is equal to M2 x2 double dot. Isn't it? So you have this one M2 x2 double dot plus by 2k x2 minus by 3k, this one x1 by x2 equal to 0. Another equation. Then you open up the bracket for both, yeah? You have m1 x1 double dot, couple of minutes, plus k, this one k1 x1, but you have this one k1, this one is not, no, sorry, this is not k1, it is not k1, this one is k1, only k, it's not k1, yeah, it's only k, otherwise it become another variable, k, so is this one also not correct, k only, isn't it, k, so you have k x1, you have 2k also x1, so you have k plus 2k become 3k x1, isn't it? So put it there, 3k x1. Am I correct or not? This one k, this one and the 2k become 3k x1. So 3k x1. Yes or no?
Yes, doctor.
Isn't it? 3k x1. Then we have plus, this one plus, but this one minus become minus. 2k x2 equal to 0. Then you start factorizing. So this one will be one. This one will be sorry, the wrong thing, factorizing wrong thing. You cannot factorize this one because we already have k1 and k2. Just leave it like that. Do this one. This one is m2 x2 double dot plus this one 2x2 x2. This one 3k x2 plus you have 5k x2. Correct? Minus by 3k x1 equal to 0. Isn't it? Yes or no?
Yes, doctor.
So you have two equations. So what is the next one? What is the next one? What is the next one? Check, yeah, my calculation this one, yeah, sometimes my calculation is not correct, but the method, inshallah, correct, yeah. Check all the numbers and all the equation because I have no ample time to check, yeah. Then what will be the next one? This is equation of motion, huh? So what is the next one? Solution, yes, solution. So let x1 or let x, cut it short because you don't have a lavish time to put everything. So just put x equal to a sine omega t and x double dot split x double dot because there's no x dot equal to this one omega squared negative a sine also omega. Then take this one and put it in the equation. How is it? Let's see this one, yeah, mn m1. This one negative become negative omega what? Omega square. You have a1, isn't it? You have a1. Then you have plus 3 x1 will be, of course, we have a1. This one be sine. This one will be x1 be here, isn't it? So you put it here. This one sine. Oh, I did mention a couple of times that you can also use this one as a big brackets. It's easy for you to simplify rather than so many steps after you reach the final equation. Just put it here plus 3k, put it here a1. Then you minus by 2, kx2 will be a2. Correct? 2k k will remain this one. Okay. Then big bracket sine omega t equal to 0. Then you have let sine is not equal to 0. Then you have what? You have 3k minus by m1 omega square, isn't it? A1 equal to 2k a2. One equation. This one put in matrix. For what? For determinant. Remember? For determinant. If you are not sure, don't worry. This one, put it in minus. Okay, it's still okay. Equal to 0. Another one, same things. Another one, so same thing. After determinant, how? Determinant, omega equal to 0. After determinant, you look for frequency equation. The frequency equation must be in the form of what? Must be in the form of what? Must be in the form of whatever you have here, omega power of 4. Whatever you have here, this one omega power of 2. Plus you have this one equal to 0. Then quadratic equation. Then roots of omega 1 and omega. Okay, you complete the one, then you look for mode shape. Mode shape how? Use this one for mode shape purposes. Isn't it? Where you have this one equal to. Then you have A1 by A2 is equal to A1 by A2. We have 2K divided by 3K minus by M1 omega square. Omega, this one representing omega N1 and omega N2. Then you look A1 for omega 1, A1, A2 for omega 2. Okay, I think that's about it. I'm sorry, class, I can't give you in detail as we are basically running out of time. If I have ample time with you, I can spend time and I can also do the whole thing details. But as I mentioned, this one, as I mentioned earlier, this one becoming your assignment. You can discuss with friend and submit this one 1 day before the exam dates. Okay, we come to end already. 1 minute. We already passed 1 minute. So any question? Any question?
Doctor?
Yes.
Can you share the sketch with us later in the group?
Share one?
The sketch that you sketched for this assignment. I mean this question. This
one.
Here.
Okay, I will.
Yeah.
I will save this one. Okay. Any other question?
No.
Nope. Okay. Okay, if there's no question, I will do our best in the exam. It's not only my course, the other course. So inshallah, I will pray for you for better results. To